All right, picking up from where we left off last class, we're going to talk a little bit more about completing the square. So this video is as kind of a supplemental because we did a study hall in class. So short video with the notes, and then we'll talk about them next class. And a reminder that we have the quiz coming up next Friday on sections 1 and 2. So continuing in section 1, this is the second page of the notes packet. With example 6, we're still looking at completing the square, but now we have a coefficient. So notice here that our a value is 2, whereas before we had only been looking at a values of 1. So the first steps are still the same. I want to subtract the 3 over. 2x squared minus 8x equals negative 3. But now, instead of directly going in to complete the square on that middle coefficient, I want to divide by 2. And the reason we want to do this is because so far all of the perfect square trinomials that we've looked at had a leading coefficient of 1. So when we divide this by 2, 2 divided by 2 is 1, so we get x squared. Negative 8 divided by 2 is negative 4x. And then the constant over here stays as a fraction, and that's okay. Okay, so the next step, and I'm going to go ahead and bring this down. You can keep referring to the steps on your own note packet. The next step is to go ahead and complete the square. So when we're completing the square, I'm taking that negative 4, divide by 2, I get negative 2, and remember that negative 2 is going to come up later. And then I raise it to the second power, I get 4, and that is what I am adding to both sides of the equation. So I have x squared minus 4x plus 4 equals negative 3 halves plus 4. And the whole point of doing that is so that we have this perfect square trinomial, and we can write this as x minus 2 squared. Remember that negative 2 that I said would come up again right here. There it is. Equals. Now, if I have a fraction, I need a fraction in order to add them. So right now I have 4 over 1. I need to change this to be something over 2, so I'm going to change this to 8 over 2. Now that they have the common denominator, I can add them. 8 minus 3 is 5 halves. And now this looks like what we did a couple classes ago, where we have something squared equals a constant, and we can take the square root of both sides. But when we do that, we need to use the square root property to put the plus and minus. So looking at the left-hand side, we have x minus 2 equals plus or minus the square root of 5 halves. We don't like to leave radicals in the denominator, so I'm going to multiply that by the square root of 2 over 2. This is the same as the square root of 2 divided by the square root of 2. So I get x minus 2 equals plus or minus the square root of 10 over 2. But our goal, again, is to solve for x, so I need to add 2 to both sides of the equation. I'm going to come up here for more space. I get x minus 2 equals plus or minus the square root of 10 halves, plus 2, x equals, now these are not like terms. This one has a square root of 10, this one does not, so I write it 2 plus or minus the square root of 10 halves. I can't simplify that any further. They're not like terms. Even if I put them with a common denominator, I would still have this plus or minus business going on. So the sets indicate that there are more than one answer there. There are 2 answers there, and that's our solution. Remember, do not put the set brackets into Math Excel. That's just for the purposes of our notes to indicate there's more than one answer as the solution. All right, now we're going to go ahead and look at example 7. In example 7, we're looking at the same thing. Again, we have a leading coefficient and we have a constant. So the first step, subtract the 8. We get 3x squared minus 9x equals negative 8. And then our next step, divide by 3. We don't want to have that coefficient. Divide by 3, divide by 3. X squared minus 3x equals negative 8 thirds. Okay, and then we're going to complete the square. Now, even though this isn't an even number, we can complete the square. We'll just end up with a fraction. Divide by 2, negative 3 halves. This will come up later. Raise it to the second power. Negative 3 halves squared. I end up with 9 fourths. Remember, squared means I'm multiplying it by itself. This is what I'm adding to both sides. X squared minus 3x plus 9 fourths equals negative 8 thirds plus 9/4. Looking at the left-hand side, this is a perfect square trinomial, x minus 3/2 squared equals, now on the right side I have to add these fractions. In order to add fractions, I have to have an LCD. So negative 8/3 plus 9/4, I'm going to do it over on the side. My LCD is 12. So I have to multiply this by 4/4 and this by 3/3. Negative 32/12 plus 27/12. Negative 32 plus 27 is negative 5/12. So on this side I have negative 5/12. Okay, now I have a perfect square. I can use the square root property, meaning I take the square root of both sides. I decided to take the square root, so I need the plus or minus. So I have x minus 3/2 equals plus or minus, and I'm going to go ahead and split my radical. Square root of negative 5 divided by the square root of 12. The reason I decided to use that quotient property there is because both of these simplify a little bit, but not all the way. So I'm going to keep looking. X minus 3/2 equals plus or minus the square root of negative 5. We have that negative under the square root. So I times the square root of 5 divided by 12 is 4 times 3. So 2 times the square root of 3. I'm kind of brushing over some of the things that we've talked about in previous chapters. But if you want more details of step by step, we can talk about that. Okay, I'm going to continue this right here. I need to add 3/2. So x minus 3/2 equals plus or minus I times the square root of 5 divided by 2 times the square root of 3 plus 3/2 plus 3/2. But I also need to rationalize that square root of 3. I'm going to do them together in one step. X equals, not like terms, so 3/2 plus or minus I times the square root of 15 divided by 2 times 3 is 6. And then the very last step, I'm going to scoot this down a little bit. The very last step is to write this in a plus bi form. I have the a and I have the bi, but the I should go last. So x equals 3/2 plus or minus the square root of 15 over 6, I. Two different answers, so I'm going to write them in set brackets. Again, do not use set brackets in Math Excel. All right, let's look at the next page. We are skipping objective 3 for now. So you can just put an X through the word objective 3, and that will be a reminder that we skipped this for now, but we might come back to it. So don't color out the whole lesson or color in this whole box. Just an X through objective 3. The last thing I want to cover in this video is the quadratic formula, and I'm going to show you 1 or 2 examples on how to use it. So the quadratic formula is a way that we can solve quadratic equations without having to use the square root property or completing the square. And the way we come about this is by actually completing the square on a general equation. So the equation in standard form here, and we leave it with all the variables, complete the square, and then we come up with this formula. Okay, so the quadratic formula is derived by completing the square for the general equation, the general quadratic equation. We will derive it in class. It's not something I expect you to know, but I think it's a pretty neat mathematical feat to see. And this quadratic formula, I do expect you to learn it. There's a song that can help you remember it. I'll play it in class, but also I'll give you a link to it on YouTube so that you can listen to it at home to help you remember it. All right, so let's take a look at how we use this in example 1. Example 1, so notice our equation here has a, b, and c. We need to be able to identify those from our equation. It needs to be in descending order and also set equal to 0. So this is our standard form. So then we can find that a is 3, b is 16, and c is 5. We've talked about doing this in class, but you'll have plenty of practice doing this as well. So when we're looking at this, we say x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I wrote the equation. I'm not always going to write the equation, and now I'm going to substitute into it. B is 16, so this is negative 16 plus or minus the square root of b squared. 16 squared is 256 minus, I'm going to write this part out because I don't want to do all that multiplication in my head. 4 times 3 times 5 all divided by 2 times 3 is 6. Simplifying, negative 16 plus or minus the square root of 256 minus 4 times 3 is 12 times 5 is 60 divided by 6. Again, negative 16 plus or minus 256 minus 60 is the square root 196 divided by 6. Now the square root of 196 is actually 14. So we get negative 16 plus or minus 14 divided by 6. Now these are all integers. I don't have any square roots anymore. I don't have any i's. So I'm actually going to solve this in its two cases, the plus and the minus. Negative 16 plus 14 over 6 equals negative 16 plus 14 is negative 2. So I get negative 1/3. And then so that was the plus, and now I do minus. Negative 16 minus 14 over 6 equals negative 30 over 6, which is negative 5. So we have two answers, actual numerical answers. So we have that x equals negative 5 and negative 1/3. Two options, two answers. I still put it in a set. Again, on Math Excel, it does not have you put the set brackets. Okay, and we'll do one more example with example 2. All right, example 2, we actually have options here. We could complete the square on this, but since we're learning the quadratic formula, we'll go ahead and use that. And then in class, maybe I'll do completing the square, and we'll do example 3 in class. Okay, so looking at example 2, I'm looking to use the quadratic formula. So I need to put this into standard form set equal to 0. So I need to subtract 3 from both sides. I get 2x squared minus 4x minus 3 equals 0. Then I find that a is 2, b is negative 4, and c is negative 3. So I find x equals the opposite of b, so negative b. b is already negative, so its opposite is positive. 4 plus or minus the square root of b squared, negative 4 times negative 4 is 16, minus 4 times 2 is 8, times negative 3. Well, minus, let me write it, 4 times 2 times negative 3, divided by 2 times 2 is 4. So I have 4 plus or minus the square root of 16. Now I have a negative times a negative. This is going to become positive. 4 times 2 is 8. 8 times 3 is 24. So I have plus 24 divided by 4 equals 4 plus or minus the square root of 40 over 4. Okay, now the square root of 40 simplifies. Equals 4 plus or minus 2 times the square root of 10 over 4. I'm going to continue this here. X equals, I'm just copying it first, 2 times the square root of 10 over 4. Well, look at all these even numbers that I have. I wonder if I can simplify. Well, in order to simplify a fraction, I need to factor first. So what can I factor out of the numerator? I can factor out a 2. And I'm left with 2 plus or minus the square root of 10 divided by 4. So now the 2 and the 4 can simplify. And I get that x equals 2 plus or minus the square root of 10 over 2. Okay, now I have a square root of 10. That means I'm not going to get numbers if I split this into the plus or minus. So we can leave it in this form. And I have two answers, so I'll do the set brackets. But again, on Math Excel, you do not do the set brackets. That's it for this video, okay? So just kind of ponder that, and we'll do more work on this in class. The rest of your homework is just to do that completing of the squares worksheet as directed on Blackboard.